Alright, you are welcome again. We are still treating complex numbers. Now let's take this question. Let z1 equal to 2 plus 3i and z2 equal to 4 minus 5i. Write the following complex numbers in the form x plus iy. Now we have number 1, 5z1 plus 3z2, all in bracket, raised to power 2. Number 2, z1 plus z2, all over z1 minus z2. Number 3, re open bracket z2 squared, close bracket, times open bracket re open bracket z2 close bracket, close the big bracket, raised to power 2. Number 4, conjugate of z1 all over z2. Number 5, conjugate of z1 divided by conjugate of z2. Alright, yes, this is what we are asked to solve. Now let's see how we're gonna be. Solution number 1, we have 5z1 plus 3z2. We have 5z1, that is to say 5 times z1. Then we have 3z2, that is to say 3 times z2. Now let's go. I'm going to say 5 open bracket z1, and then you know that z1 is 2 plus 3i, close bracket, plus 3 open bracket z2. Z2 is 4 minus 5i. Now let's open this bracket. 5 times 2, 10. 5 times 3i, 15i, plus 3 times 4, 12. 3 times minus 5i, we have minus 15i. So when you say plus 15i minus 15i equal to 0, and then 10 plus 12 is equal to 22. But you discover that we have 5z1 plus 3z2 all in bracket raised to power 2. So we have found the content in the bracket. Now let's square it. Okay, so we have 22 squared, and then 22 squared is equal to 484. 484. All right, yes. Now let's take number 2. All right, number 2, we have z1 plus z2 all over z1 minus z2. Okay, so we have z1 to be 2 plus 3i in bracket plus z2 4 minus 5i in bracket all over z1 2 plus 3i in bracket minus open bracket 4 minus 5i. So in this numerator, real part plus the real part, imaginary part plus the imaginary part. Okay, so we have 2 plus 4 going to give us 6, and then plus 3i minus 5i going to give us minus 2i. Also in our denominator, we're going to say 2 minus 4 is going to give us minus 2, and then plus 3i minus 5i is going to be plus 3i plus 5i. Okay, this minus will give us plus, so we'll have 3i plus 5i equal to plus 8i. So we are having 6 minus 2i all over minus 2 plus 8i. Okay, now let's perform the division here. Okay, so in performing this division, we're going to multiply the numerator and the denominator by the conjugate of the denominator. All right, now let's go. We have 6 minus 2i all over minus 2 plus 8i. Now the conjugate of the denominator will give us minus 2 minus 8i. Okay, now let's multiply. We're going to have 6 minus 2i in bracket times minus 2 minus 8i all over minus 2 plus 8i in bracket times minus 2 minus 8i. Okay, so when you perform the operation in a numerator, we're going to have minus 12 minus 48i plus 4i plus 16i squared. Then in our denominator, that is all over, we're going to have 4 plus 16i minus 16i minus 64i squared. Okay, so in a numerator, minus 48i plus 4i is going to give us minus 44i. And then we have plus 16i squared. I squared is the same as minus 1. So minus 1 times plus 16 is going to give us minus 16. So we're going to have in a numerator minus 12 minus 44i minus 16. Alright? All over. In our denominator, plus 16i minus 16i is equal to 0. And then minus 64i squared. I squared minus 1. So minus 1 times minus 64 is going to give us plus 64. So we're going to have 4 plus 64. Okay, good. Now we're going to say minus 12 minus 16 is going to give us minus 28. Then we have minus 44i. All over 4 plus 64 is going to give us 68. So we have minus 28 minus 44i all over 68. Okay, now we're going to, from our question, we are asked to write it in the form x plus iy. As it is like this, it is not in x plus iy form. Okay, so to write it in x plus iy form, we're going to split it into 2. Okay, so we are going to have minus 28 all over 68 minus 44 all over 68i. Okay, we're going to write it like this: minus 28 all over 68 minus 44 all over 68i. All right, now let's go. Number 3. Number 3, we have RE over bracket Z2 squared. So this RE simply means the real part of Z2 squared. It simply means the what? The real part of Z2 squared. Then we'll say times the real part of Z2. Then you're going to get the real part of Z2 and then squared it. Okay, now let's go. We have our Z2 to be 4 minus 5i. All right, now we're going to find Z2 squared. We're going to find what? Z2 squared. So Z2 squared is going to give us something like this: 4 minus 5i in bracket raised to power 2. That is the square. Okay, now we can open this into 2 places, that is into 2 brackets. So if we do so, we're going to have 4 minus 5i in bracket times 4 minus 5i in bracket. Okay, so let's open this bracket. We're going to say 4 times 4, we have 16. Then 4 times minus 5i, we're going to have minus 20i. Then minus 5i times 4, we're going to have minus 20i. Minus 5i times minus 5i, we're going to have plus 25i squared. Okay, so minus 20i minus 20i is going to give us minus 40i, and then plus 25i squared. I squared minus 1 times plus 25 going to give us minus 25. So we are having 16 minus 40i minus 25. Okay, so when you say 16 minus 25 is equal to minus 9. Okay, they will have minus 9 minus 40i. Okay, so here we have found our Z2 squared to be minus 9 minus 40i. Okay, so the question says the real part of Z2 squared. So the real part of Z2 squared is going to give us minus 9. Okay, the real part of Z2 squared is going to give us minus 9. Now let's go to the second side of it. Second side of it say open bracket RE of Z2 close your bracket raised to power 2. Okay, so that means in our Z2 we have 4 minus 5i. So what is the real part of this Z2? The real part is 4. Then square of it is going to give us 4 squared equal to 16. So in our question we have the real part of Z2 squared times open bracket real part of Z2 squared. Okay, so we have solved for the 2 and then we have obtained their values. Now let's multiply them. We're going to have minus 9 times 16. Okay, because the first part, which is the real part of Z2 squared, is giving us minus 9, and then the other side is giving us 16. Okay, so minus 9 times 16 is equal to minus 144. Okay, minus 144. Okay, let's take number 4. Number 4 say the conjugate of Z1 all over Z2. The conjugate of Z1 all over Z2. Now let's See, our z1 is 2 plus 3i, and then z2 4 minus 5i. So let's find z1 all over z2. That is z1 divided by z2. Okay, now let's find it. So for us to solve this, we're going to have 2 plus 3i all over 4 minus 5i. Okay, so let's multiply the numerator and the denominator by the conjugate of the denominator. So to do so, we're going to have 2 plus 3i in bracket times the conjugate of denominator is going to give us 4 plus 5i. Okay, so times 4 plus 5i all over 4 minus 5i times 4 plus 5i. So when you multiply the numerator, you're going to have 8 plus 10i plus 12i plus 15i squared all over 16 plus 20i minus 20i minus 25i squared. Okay, now let's go. In our numerator, we have 10i plus 12i is going to give us plus 22i, and then 15i squared. I squared is the same as minus 1, so minus 1 times plus 15 is going to give us minus 15. So we have 8 plus 22i minus 15 all over, in our denominator I will say 20i minus 20i is going to give us 0, and then minus 25i squared. I squared is the same as minus 1, so minus 1 times minus 25 is going to give us plus 25. So we're going to have 16 plus 25. Okay, now let's go. In our numerator we have 8 minus 15, so 8 minus 15 is the same as what? Minus 7. Okay, then we'll have minus 7 plus 22i all over 16 plus 25 will give us 41. So we are having minus 7 plus 22i all over 41. Okay, this is not in the form of x plus iy, so let's write it properly in the form of x plus iy. So we're going to have minus 7 all over 41 plus 22 all over 41i. Okay, minus 7 all over 41 plus 22 all over 41i. Okay, so we have found z1 all over z2. Okay, now our question says the conjugate of this z1 all over the z2. So we have found it. So to take the conjugate of it, we're going to have the conjugate of z1 all over z2 is equal to minus 7 all over 41 minus 22 all over 41. Hello, the one we solved, we have z1 all over z2 to be minus 7 all over 41 plus 22 all over 41i. Then the conjugate of it is going to give us minus 7 all over 41 minus 22 all over 41i. All right, good. Let's take number 5. Okay, number 5 says the conjugate of z1 all over the conjugate of z2. The conjugate of z1 all over the conjugate of z2. Now let's go. We have z1 to be 2 plus 3i, and then z2 to be 4 minus 5i. So the conjugate of z1, what is it going to give us? The conjugate of z1 is going to give us 2 minus 3i. Then the conjugate of z2 is going to also give us 4 plus 5i. Okay, so let's arrange it. You say the conjugate of z1 all over the conjugate of z2. So that means it's going to look like this: 2 minus 3i all over 4 plus 5i. Hello, this 2 minus 3i is the conjugate of z1, and then 4 plus 5i is the conjugate of z2. Now to perform this operation, we're going to multiply the numerator and the denominator by the conjugate of the denominator. Okay, now the conjugate of denominator here, we have 4 plus 5i as the denominator, so the conjugate of it is going to give us 4 minus 5i. Now let's go. We're going to have in our numerator 2 minus 3i times the conjugate 4 minus 5i all over 4 plus 5i times 4 minus 5i. So when you perform the operation in the numerator, we are going to have 8 minus 10i minus 12i plus 15i squared. Okay, now in our denominator, we're going to have 16 minus 20i plus 20i minus 25i squared. Okay, good. In our numerator we have minus 10i minus 12i, so this is going to give us minus 22i. Okay, now 15i squared, I squared is the same as minus 1, so minus 1 times 15 is going to give us minus 15. So we'll have 8 minus 22i minus 15. So all over, in our denominator we have minus 20i plus 20i is going to give us 0, and then minus 25i squared, I squared minus 1, so minus 1 times minus 25 is going to give us plus 25. So in our denominator we're going to have 16 plus 25. Okay, now let's go. In our numerator, 8 minus 15i is going to give us minus 7. 8 minus 15 is going to give us minus 7. Then we have minus 7 minus 22i. All over, 16 plus 25 is going to give us 41. So therefore we are having minus 7 minus 22i all over 41. Let's write it properly in the form of x plus iy. So we're going to have minus 7 all over 41 minus 22 all over 41i. Hello. So the conjugate of z1 all over the conjugate of z2 is giving us minus 7 all over 41 minus 22 all over 41i. All right, so when you look closely, you discover that our number 4, which is the conjugate of z1 all over z2, is the same as the conjugate of z1 all over the conjugate of z2. They gave us the same thing. All right, good. Let's go. Let's take more example. All right,